Great. So, hello, museum families, and welcome to RBCM at Home Kids, a play date through screens across British Columbia and the world. The previous sessions are recorded, and you can find them on our Royal BC Museum YouTube page. My name is Chris O'Connor, and I'm a learning program developer at the Royal BC Museum. The museum and my home is on the territory of the Lekwungen-speaking people, the Songhees and Esquimalt nations here in Victoria on Vancouver Island. I'm an uninvited guest on this territory and grateful to live, learn, and raise a family on this land. So May is BC Mining Month. So today we're exploring all things rocks and minerals. And in my experience working here at the Royal BC Museum, the top things kids absolutely love are dinosaurs, but closely behind are rocks. Because while you might be able to find and collect, you might not be able to find and collect dinosaur fossils in your backyard. Most likely you can find a pretty cool selection of rocks. And for many kids, and I'll include myself, those rock collections became like a home museum on bedroom shelves across BC. Yesterday was International Museum Day, and there is nothing that gets to the core of museums like the process of being curious about the world around us. We're collecting responsibly and respectfully to better understand that world, and then puzzling out why those objects have meaning and purpose. So let's get into that today. And I'm so happy to be joined by Shirley Rosichuk from the Stewart Museum in Stewart B.C. and Allegra Whistler and Jason Kernier might come back from Minerals Ed BC, and it's such a pleasure to have you both here. And I'm so looking forward to learning more about rocks and minerals.
Perfect.
So welcome.
Okay. Well, thanks, Chris. I'm really excited to be here today as well with our viewers and my good friend Allegra Whistler. Today is all about rocks, and part of my job here at the Stewart Museum is to look after a very, very special collection of rocks and fossils from the area. Some really glitter very, very brightly, and we'll hold it up. And some have very unique and unusual shapes like this. You'd almost think it was an old piece of tin can, but it's a lovely piece of copper. All right. And then we also have fossils here in our collection, like this one here. And you can all see those wonderful shells inside the fossil collection in that rock. And now I'm going to pass you over to Allegra and let her tell you a little bit about herself. Allegra?
Sure. Thanks, Shirley, and thanks, Chris. It's really cool to be here with everyone today, so thanks for joining in. My name is Allegra Whistler, and I am a geologist. I work for Minerals Ed. Minerals Ed is based in Vancouver, and we are a nonprofit charitable organization. We are dedicated to supporting teachers and students in BC for all things geoscience and earth science related, for activities and classroom workshops and teacher workshops. And that's what we do. And I guess without further ado, I will attempt to share my screen and get the presentation started, if that's okay with everyone.
Perfect. Thanks, Allegra.
Cool. Wish me luck. All right. One moment. And I'm just going to get the chat box up on the side if I can. Perhaps I can't, but that's okay. All right, so yeah, today's workshop is called We All Rock. I'm really excited to be here. Thanks for joining us. Shirley, Chris, and I are coming from 3 different locations over the province today. So Shirley is up in Stewart in northwestern BC up there. I mentioned I'm from Vancouver, so that's down in southwestern BC. And Chris is in Victoria, right down there as well. So we're all coming to you from different locations. And so what you're looking at right now is a map of BC. It is not any old map of BC. There's something special about it. This map is a geological map of BC. So you can see all the different colors there. We got like a rainbow of colors throughout the province. Well, every single different color is basically a different type of rock. Geologists in BC are so lucky because, well, as you can see on the map, we have so many different types of rocks to explore, and that makes our jobs really interesting. Sometimes a little difficult, but always interesting. And there are so many different exciting topics to talk about in earth sciences and geology. For example, we could talk about volcanoes, we could talk about earthquakes and fossils and plate tectonics, the layers of the earth. We could even talk about the geology on other planets like Mars. But today, we will be learning about the rock cycle. The rock cycle and the three major types of rocks: igneous, metamorphic, and sedimentary. So I can't see the chat right now, but that's okay. Just put in the chat, let us know, have you heard about the rock cycle before? And just let us know in the chat if you have or if you haven't. And if you haven't, no worries, because by the end of today, we will all be experts.
So just to let you know, Allegra, we have 3 yeses so far.
Great.
That's awesome.
Cool. Okay. Yeah. So by the end of today, we'll all be experts on the rock cycle. So back to you, Shirley.
All right. So I bet a lot of you collect rocks. I know I do. Every time I go out to the mountains here, I'm always bringing home a little bit of a different rock. And what's this? What's that? So rocks are not alive. They are a very solid piece of material. And some are heavier than others, some are lighter than others, some are beautifully colored, and some are just plain old gray in color. They're made with a mixture of very different minerals or ingredients. And we'll go to the next slide. Today, I want you to think about mixing all those ingredients. And I have a cookie with me. We're going to pretend that this cookie is like a rock. And in it, it has many different ingredients: some flour, sugar, salt, baking powder. This one has some chocolate chips, and it also has Smarties in it. Maybe your rock would have sparkles on the top of it. So all of them mixed together would make a very nice cookie rock. Okay, next slide. So now let's take a look at a real type of a rock and what ingredients might be in it. So this has boronite in it. It has quartz in it. It also has 2 colors of feldspar in it. One is a pinkish color and one is a grayish color. So we mix all of those together, and this mixture gives us a rock called granite. And now we're going to go to Allegra again, and she's going to tell us why rocks are so important to us in our everyday life today. All right, Allegra.
Thanks, Shirley. Yeah, so now we know what rocks are, what they're made of, and it's important for us to know why rocks are important. Why do we even care? Well, first of all, rocks are all around us. They're underneath our feet, they're underneath our homes and our schools. They make up the mountains and volcanoes that we see. They also make up islands. They pretty much make up everything that we stand on. They make up the whole crust. So I don't know if you can see behind me, but I have kind of a diagram of the layers of the earth, and just the blue outline, that's the crust. And that's where we live, and it's entirely made of rocks. Rocks can also give us clues to Earth's 4.6 billion year old history. That's a really, really long time. So geologists can look at rocks, minerals, and fossils, and from those, we can learn about how Earth has changed over the millions, billions, thousands, and hundreds of years. We can also learn how life has evolved through time, and we can also learn about the climate and how it's changed through that 4.6 billion years. Lastly, rocks and minerals are really important because they're a non-renewable resource. Non-renewable resource might be a new term for some of us, and that's okay. So basically, a non-renewable resource is something natural. It comes from the earth. Humans don't make it. And a non-renewable resource is something that humans use up faster than the earth can replace it. So we need rocks and minerals every day, and we need to mine them because rocks and minerals, the metals and the minerals and the rocks, they make up our everyday objects. For example, a car, your backpack, your cell phone, electric cars, glass windows, building homes and houses, solar panels, and even kitty litter. All those things come from rocks and minerals that need to be mined. And it's also very important, since these are limited resources, it's really important that we manage these resources responsibly so that we don't use them all up, because if we use them all up, there might not be any left. So that's why it's important to recycle. And it's also really important to be conscious and respectful of the environment when we are taking out these resources. Back to you, Shirley.
Okay. So great. So this picture of this beautiful rock that we have here in the Stewart Museum was taken by Below BC, and it is Below BC has a wonderful website, and if you're a rock hound or a young person wanting to learn more about the rocks below the Earth's surface here in British Columbia, you go onto their website and you'll learn lots about it. You'll be able to see every little nook and cranny in the rock, including magnifying it. So let's take a closer look at this rock and see what minerals ingredients are in it and what it might be used for. So when we look really, really closely at this rock, we will see the white, which is quartz, and some chalcopyrite here, and galena. Chalcopyrite is a copper mineral, and galena is actually a lead mineral. But within the rock itself, it contains very, very tiny amounts of zinc, silver, and gold. So small, in fact, that you would need a microscope to actually see it before it was processed. All right. So we need to mine.
So sorry, can I just jump in for a second? We have a question from M and Pell. What's the difference between rocks and minerals?
Okay, well, actually, I'm going to go back to a slide from before, if you don't mind.
Sure.
Shirley, do you want to take it?
Nope, I'll let you do this.
Sure. Yeah, that's a
right
great question. Great question. So basically the mineral, remember how Shirley was talking about how the minerals are the ingredients of the rock. So minerals make up the rock, and a mineral is something that's naturally occurring. It's natural, humans don't make it. It's inorganic, so it's not got carbon on it most of the time, and it's solid and it's made of elements. And a rock is just the same thing, but it's just made up of all those minerals, a mixture of minerals, the ingredients that make up the rock. Chris, can you let me know if that helps answer their question?
Yeah, I think that's a good.
Okay, cool. So basically minerals are the building blocks, the ingredients of a rock. We'll go back to Shirley's slide.
Perfect. Okay. So to get all these wonderful minerals, first of all, we have to remove it from the ground. And by the process of doing that is mining. The rocks are then crushed and processed through different types of processing to separate all those minerals. And these minerals in turn become the resources we use in our everyday lives. In particular, this rock could have been mined for copper for the electric wires, lead for maybe even your pencils, or medical equipment like the apron for an X-ray machine when you go to the dentist, silver and gold for jewelry and coins, and also some medical treatments. They use gold in, and silver dressings to help heal wounds, zinc for car batteries, and many, many, many more things. So back to you, Allegra.
Okay, great. So now we've gone over what rocks are made of minerals, the ingredients. We know why rocks are important, and we've learned a little bit about mining. Now it's time for a little brainstorm. So Jason, I believe, is going to put the link in the chat. So if you go to this website right here, Poll EV, and type that in, you can put in your answer. So the brainstorm is, take a look around the room you're in, or maybe you're outside. Just look around, try to find a couple objects that you think are made of rocks and minerals that were mined. And I will get to that page. So basically we can see everyone's live responses at the same time. And there it is. So people are already putting a few answers in. Shirley, can everyone see that?
Yes.
Yeah, so start
Awesome.
putting your answers in. We'll give you about 2 minutes. Look around the room, find some objects that are made of stuff that it comes from rocks and minerals that are mined. So anything with metal definitely counts.
Perfect. So Allegra, I'm just going to show this beautiful little piece of my collection, which is made from mineral. And this was a special commemorative coin that was made in 1965 to commemorate the opening of the Grand Duke mine tunnel. So it is made with beautiful copper minerals, and it's here to see in our mining room on display.
Perfect.
And just to add, just as people are adding in this brainstorm suggestions, we just have two questions. One is, can zinc be made into photo paper? And the other question is, how do humans impact the rock cycle?
Ooh, those are two really pack-loaded questions. For zinc for photo paper, I'm not sure about that one. I just don't have the knowledge about photo paper, but I do know that like back when photography was film-based and you had to process the film, there's a lot of chemicals used. I think silver was one of the major chemicals used to produce those film photos. And the second question is, how do humans influence the rock cycle? And that is a great question. Well, I'd say, how do we influence the rock cycle? Well, the rock cycle is a pretty big thing because it's happening everywhere all the time, all over the world. I guess one of the main things that comes to my mind is like plastic pollution, and how, we've heard about plastic pollution in the oceans, the Marianas Trench, from the deepest parts of their crust to the highest parts on Everest. And I know that some rocks are, there's some plastic rocks being made, like some sedimentary plastic rocks. And I guess also building all our cities, all the concrete will definitely be part of the rock cycle now, because it's here to stay for the meantime. So, and Shirley, if you have anything to add on to that?
Yeah, well, maybe some of our biggest impact on the rock cycle will be the use of our resources. But in going back on that is what we need to do to recycle those resources and keep them flowing, so that we're renewing our cycle all the time. Even though it may not be from Earth, it's from, it's keeping those resources recycling and reusing.
That's a great question. That could be a big brainstorm question. I could make a word cloud just for that. So I'm just going to read a couple of the answers off, and then we'll get back to the presentation. So we got windows, bottles, a phone, PS4, a hammer, jewelry, ceiling. Some of the words get split up. Heaters. Yeah, that looks really good, everyone. So a really good brainstorm. And we're going to hop back to the presentation. So thanks for participating. Okay, back to you, Shirley.
Okay, so all of those objects we talked about in the brainstorm, the elements to build them, or the minerals that were used to construct them, were all came from rocks, and they were mined. This is a map that shows all the active mines in British Columbia. And right now we have 9 metal mines, about 7 coal mines, 30 industrial mines, and over 1,000 aggregate mines. Now, we're going to take a little closer look at the mining and mining exploration projects here in northwestern BC. So let's take a look at that map. And the yellow star shows you where Stewart is. And you'll notice that there's a triangle right around Stewart and some of the area close around it. Geologists call this area the Golden Triangle. And the Golden Triangle is the hub of mining activity in our area. And in 2020, it was estimated that more than half of the total of the exploration costs in the province of British Columbia were focused right here in this area. There's been mining up here since the late 1800s on the tail of the Yukon Gold Rush. One little different thing about our area, most of this, rather than finding big nuggets in the water, is that you have to mine it mostly underground. Some is very close to the surface, but most of it is hard rock mining. So some of the mines we are very, very familiar with, and the exploration companies in our area, those would be Ascot Resources, Skeena Resources, Scotty Resources, Pretium Resources, and Seabridge Gold. all within our golden triangle. So now let's find out from Allegra more about rocks and the rock cycle.
Sure. I think we even have some geologists from Ascot Resources joining us. I saw them in the chat earlier.
Oh, great. That's awesome.
Okay,
Well, hello
everyone.
to all of those. We're really happy for them to be watching today.
Okay, everyone. So it's time for the main activity for Wheel a Rock on the rock cycle. So now if you have a modeling clay, a plasticine, or Play-Doh near you, it's time to get out your 3 different colors. If you don't have those with you right now, don't worry about it. This workshop is recorded, so you can always join back in the activity later on. So first we'll be making 3 different types of rocks with our clay. We'll be making an igneous rock, then a sedimentary rock, and then a metamorphic rock, okay? So the first rock that we're gonna make is an igneous rock. So igneous rocks are made when magma or lava cools and hardens into minerals and rocks. So you may have seen some videos of lava spewing out of Hawaii or Iceland. So that's the lava and the magma we're talking about. And you can kind of see a little picture here of the magma, which is underground. When it comes out of the ground, it's called lava. And that's how igneous rocks are made. So this picture is of an igneous rock from the Golden Triangle. And you can see the different minerals inside, all these different colors and shapes. They're different minerals, the ingredients that make up this igneous rock. And you might notice that some of these, like the pink minerals, are kind of bigger than the rest of the minerals in the background. Well, those pink minerals are bigger because they've had more time to cool and more time to grow. So think about it, if you have an older sibling, an older cousin, or maybe an older friend, that older person, they might be taller than you just because they're older and they've had more time to grow. So all these other minerals, you can see some black and some kind of like yellowish bronze colors in the background. Those are the other minerals. They're smaller because they haven't had as much time to grow, but they're equally as important in this rock because without them, it wouldn't be this rock. Okay, so we're gonna get started on making our igneous rock. So first choose 2 out of your 3 clay colors. And what you wanna do is you wanna make about 4 to 6 small balls of clay in those 2 colors, about the size of your pinky nail. So they're gonna be really tiny. And we'll give you guys, we'll give everyone a couple minutes to do that. So make maybe like 4 balls of each color the size of your pinky nail.
That's awesome. So I have a little sample of a igneous rock here in the museum. And this came from one of our very old mines at the Premier for Ascot Resources that own it now. So very cool.
And Chris, were you about to say something?
Oh, there were just, there were a few questions when,
Sure.
Can diamonds melt?
Yes, diamonds can melt, but they have, like, the temperature diamonds are formed at are super, super high. You're not, I can't remember the temperature off my head, but it's going to be in like the very high hundreds, possibly the thousands of degrees Celsius.
Great.
Good question. I think your diamonds will be okay on the surface of the earth though. And if you want to test it out, you could put it in the oven. I would recommend that. It's just a joke. And if you guys are done making your small balls of clay, just let us know in the chat and then we'll move on. We'll give you another minute. And don't worry if you don't have them all made.
Cool.
I think it's probably okay to.
Good to go? Cool.
All
right. Sweet. So step 3, so you're going to take your 3rd color, number 3, and you're going to make some medium-sized balls, about the size of your thumbnail. So they're going to be a little bit bigger than those other balls you're making. And we'll give you about a minute to do that as well. So basically, the clay colors, the little balls you're making up right now, these are the minerals, the ingredients to our igneous rock. And the bigger balls are the ones, the minerals that had more time to grow, just like those pink minerals that we saw in that picture.
While they're doing that, we have another great question.
Sure.
Why are some lava rocks red and others black?
Ah, a very good question. So one, it could be, so I'll have kind of two answers. One, it can be the minerals in the rock. So maybe the minerals in the black rock, those minerals are more dark colored. Red rocks, maybe the red ones have more red minerals. But I think the better answer for that question is oxidation. So you might have seen iron, like maybe metal or cars, when they've been outside for a really long time, they start to rust and they turn kind of red. Yeah, thank you, Shirley. So if we can see Shirley's screen, just keep holding it up, Shirley, for a sec.
Okay.
Yes, just like that rock Shirley's holding, it's kind of like red and orange. So basically that rock has rusted, the iron has rusted. And lava rock, so if it's red, it has had more time to oxidize, or it may have been on the top of the lava flow. So the iron has rusted. And that's the same reason Mars is red, because all the iron on Mars has oxidized and rusted and turned red. Really good question.
Perfect.
Cool. I'm going to move on to the next step. Oops. So now you're going to gather all your little clay balls and you're going to combine them into one large ball, just like the pictures are showing below. You're going to kind of like press them together so there's no gaps. You might want to shape your rock so it's not a perfect circle. Maybe you want to like give it some flat edges, make it look rock-like. And we'll give you a minute to do that. And Chris, was there another question?
There was a question earlier and Jason answered it, but I think it's a really good question and worth saying out loud. So what makes certain rocks valuable?
Sure. And then do you want to read Jason's
Yeah, so Jason said the minerals within the rocks will determine how valuable it can be. A rock with a lot of gold or silver in it will be very valuable. If it's a rock is very rare, like a meteorite, it can also be very valuable. So I guess maybe that how we even define what valuable is an important part of that question.
Yes, definitely. Okay, so
and we have, just to let you know, we have just a few more minutes until the end.
Yeah, okay, that sounds good. Well, congratulations, everyone. You've made an igneous rock. So remember, igneous rocks are made from the cooling of lava and magma. And it's important to note that not all igneous rocks are going to look like this. Some of them will have holes in them, like this piece of pumice. Those holes are from gas bubbles escaping the lava. Some igneous rocks will look like this. This is obsidian. It's a black glass. And you may have heard this before from Game of Thrones. And also, it's a very important rock for the First Nations people of BC because they would use it to use as sharp tools. You'd mine it and use it as sharp tools and weapons. Okay, so next we're going to go on to sedimentary rocks. Chris, we might go over a little bit of time. I hope that's okay.
For sure. Just for everyone joining in, just if you need to leave, please feel free to, but we'd love for you to stay on and be able to continue on. And also remember, we're recording this, so if you do miss anything because you have to leave, then please just watch the recording after.
Cool. Okay. All right. So sedimentary rocks are our next rocks. I'm sorry if you guys, I don't know if you see that banner when it goes to me. Anyways, sedimentary rocks are made from weathering, transportation, and deposition. So basically, weathering is when an existing rock gets broken down into smaller little pieces, maybe a pebble size, maybe a grain of sand, or maybe a piece of mud. And that's weathered from ice, wind, and rain. So after that rock has been broken down into a small piece, it's transported maybe by a glacier, maybe by wind, or maybe by a river. And that little grain is transported all the way down to its final resting spot where it's deposited. Eventually, you get layers of little grains stacking up on top of each other, and that's how you get a sedimentary rock. So now we're going to make a sedimentary rock. Get the rest of the clay. So put your igneous rock aside, get the rest of your clay, and you're going to flatten your clay into little pancakes about the size of your hand, okay? Or the size of your palm. And Shirley, did you have a sedimentary rock that you wanted to share?
Yeah, I have a couple of different sedimentary rocks.
Yeah.
This one.
Yes, you can really see the layers in that one.
Really, really cool. And this is rubber rock that would have been carried from the glaciers and worn really smooth, moving through the water and just tumbling and breaking it down and smoothing the edges from it. So it's really cool. I collect a lot of river rocks, pretty ones too. Okay.
Cool.
Go
Okay,
ahead.
on to the next slide. So when you're done making your little pancakes, stack them up on top of each other, just like that rock that Shirley showed us. So in the igneous rocks, your different clay colors for the different minerals. For this sedimentary rock, your different colors or clay are just different layers in your sedimentary rock. Okay? And once you're done that, congratulations, you have made a sedimentary rock. One cool thing about sedimentary rocks is that that's where you're going to find fossils. So if you actually have a little shell, maybe a shell from the beach with you, you can make a fossil in your sedimentary rocks that you just made. If you just gently press it into your clay, that's basically how fossils are made, more or less. Okay, on to our last rock, metamorphic rocks. So metamorphic rocks are formed from in really high pressures and temperatures. So really high pressures and really, really high temperatures, really, really hot. And basically the metamorphic rocks are changing rocks. So think of metamorphic or metamorphosis in a butterfly, caterpillar to butterfly, the rock is changing. So the high temperatures and high pressures, they make the rock more flexible. And sometimes you can get rocks with folds in them. So in this metamorphic rock in the picture, it used to be a sedimentary rock. You can kind of see all the layers there. And under high pressures and temperatures, this rock got folded in half. So that's why you can see U-shape in it. Okay, so how are we going to make a metamorphic rock? Well, take those sedimentary rocks that you just made and just fold them in half. Fold them, make a U shape, make an S shape. And as you fold them, that's the pressure and the temperature from your hands, the heat from your hands are metamorphing the rock, your sedimentary rock, into a metamorphic rock.
I've just got a couple of metamorphic rocks here, and you can see the pressure line here. And also this one with the garnets in it.
Yeah.
Really cool. Okay,
awesome. Great. And if you want, you don't have to, but if you have a ruler edge or a flat edge or maybe some tooth floss, you can cut through your metamorphic rock just to see those layers and folds a little bit better. And congratulations, you have made a metamorphic rock. So now you have made every single rock in the rock cycle. We made igneous rocks first. Igneous rocks are made from the cooling of lava and magma. Sedimentary rocks made from weathering, transportation, deposition. And lastly, the metamorphic rocks, which are formed under super high pressures and temperatures. So in this picture, you can see a bunch of arrows. They're going all over the place. Basically, it's showing that any rock, any of the three rocks that we made, can be turned into another rock. The rock cycle is basically how it explains how rocks are recycled through the earth. And yeah, that's the end of today's activity. Thank you very much. You all rock.
You all rock.
So true. And actually, if we all rock, which we do, one of the questions, and Jason, thank you for answering this with Iz's question, why are rocks so hard? Which is a really interesting response, because Jason, you said not all rocks are hard. Some are soft, like rocks made up of talc. You want to talk a little bit more about that?
Sure, yeah. So just like any cookie, depending on the ingredients in the cookie, some will be soft and chewy and some will be really hard and brittle. So for a rock, depending on the minerals that make it up, it will either be very hard or it can be very soft. So if the mineral is very soft, like talc, which is used for baby powder, very soft, that rock will be soft. But if the rock is very hard, like a granite, the one with the quartz and all that in it, it'll be very hard. So rocks differ depending on what they're made of.
Great. Allegra, do you mind, or do you have another slide to show, or do you, maybe if you stop sharing, do you want to stop? Yeah, there you go.
Sure, yeah, thanks.
And we have two other questions. Maria asks, do each of the colors of clay represent different minerals?
Yes, so in the first rock we made, the igneous rock, the different clays, they represented different minerals. In the sedimentary and metamorphic rocks, we're just using the clay to see the different layers that would be inside those rocks.
Great. And then Maria also asked, do the rocks need to be completely melted to be metamorphic?
No, they don't need to be completely melted. If they were completely melted, they would turn back into magma, and then they would eventually be turned into an igneous rock. So metamorphic rocks, they're just heated a little bit just so they are a little more plastic and a little more bendy.
And then Lucille, Phoebe, and Beatrice asked, what is your favorite type of mineral and or rock?
Yeah, my favorite mineral is boronite, copper mineral. It's called the peacock ore just because it has really pretty colors.
And the last is not a question, it's a comment from Maria saying, awesome, you guys rock, thank you.
Thank you.
Which I agree. Actually, one more question that just came into the chat from Christian and Clementine. What kind of jobs are there related to rocks and minerals?
Oh, that's a great question, and honestly, there are so many answers. The biggest one is you can become a geologist and explore for rocks and minerals. It's really fun. You get to hike the mountains and bang around and look for rocks. You could be a driller. You could be a geotechnician. You can be a mine supervisor. You could even become, I don't know, an earth science teacher. You could be a museum curator, like Shirley.
I was about to say that.
What else could you be? You could study volcanoes. You can study glaciers. You can study climate change. You can study landslides and earthquakes. You can study groundwater and hydrogeology and groundwater contamination. I know, and you can study fossils. And those are just the jobs related to rocks. With all the mining projects, they need cooks, they need first aid attendants, they need helicopter pilots. You could do anything with rocks and minerals.
We also have people that work in the labs to analyze the rock and the core. Yeah. And it's not limited to just guys out in the mine world, but ladies too.
Yeah. Actually, yeah, thanks. Thanks, Shirley. I'll just add that one of the reasons that I love geology is that it's an interdisciplinary science, which means you need to be an earth scientist, you need to know biology, you need to know chemistry, you need to know physics, and environmental science. Like earth science is where all the sciences come together to be one.
Well, thank you so much, Allegra. I mean, you and Shirley demonstrated that so well today, how all of those things come together, and how exciting the field is, and the field of inquiry around rocks and minerals is. So thank you so much for joining in, and thank you, Jason, for answering some questions in the Q&A. It's been such a pleasure to have you all be part of RBCM at Home Kids this week. And happy BC Mining Month.
Yeah.
So BC Mining Month. And I'd just like to also say thanks to our sponsors this month for really making education and inquiry about rocks and minerals and mining at our little museum a really integral part of our area in the Golden Triangle here. So thank you. And thanks Allegra and Jason and Chris for having us on the show today.
Likewise, thank you.
All right. So what we're going to do is we'll stop.